So today's video is about local large language models, or mini large language models, whatever they're called. So I've got a NVIDIA 5060 GPU, which it only has 8 gig of VRAM, but it is sufficient to run some mini large language models. So yeah, we're just going to run some and see. So if we run Llama 3.1, 8 billion. So you can see on the right hand pane, it's 5.5 gigabytes and it's 100% fitting on the GPU. So if we type a question, so if you pay attention to the utilization, you should see let go to 100 when we ask a question. Yeah, so we can see that it's using the GPU. Yeah, and that was very fast indeed. And we also have a couple of others. So this one is also an 8 billion parameter model, but it's a reasoning model, so it thinks before it responds, which means it's slower, but it would probably do a lot better at puzzle solving and any kind of benchmarks that require puzzle solving. So what happens if you want to run a bigger model? Well, so this one is a 12 billion parameter Google model. So what you'll see is that it splits the model. So it's going to run at 42% on the CPU and 58% GPU. Now, although obviously it's a bit slower, it's still a lot faster than it would be if it was entirely on CPU. I'll cancel that. And then we also have GPT OSS. So yeah, this model is even bigger and only fits about, what does it say, 54% CPU, 46 GPU. And you can see the GPU is only 11% utilization because it's so thoroughly bottlenecked waiting for the CPU. Anyway, that's enough demoing that. What I actually want to do for this video is I've got a virtual machine and what we're going to do, so this virtual machine, I've turned off its internet connection. And what that means is we can do a sort of experiment of, imagine we want to do some coding, but we don't have internet. How helpful can these mini large language models be? That's what we're going to do today. So I've set it up so this should be able to access our Llama over the network. Yeah, looks like it's working. And I knew I'd need some libraries to connect to it from Clojure. So I have preloaded those. So what we've got here is just the minimal code that I use just to test that we can actually interact with the model from Clojure. Let's make this a bit bigger. Unable to resolve. Oh yeah, I haven't evaluated the buffer. It's running, it's just being slow. Yeah, cool. Yeah, so the coding project that I thought we could do, and I haven't practiced this at all. The idea I had is, why not experiment with what we can actually do with large language models? So something that you can do that's pretty cool with local models is you can use them for sorting things. So for example, let's say you've got 50 blog posts and you want to sort them based on some sort of semantic criteria or subjective criteria. So you want to sort them based on sentiment, right? Sort these 50 blog posts based on how positive the sentiment is. So you can't just shove all of that into a large language model in one hit because it's way too much data. So you need to write a wrapper script basically and do comparisons. But the problem with this is it's too big of a project to do on this video. That would take like 3 hours. So I thought as a sort of toy project that we could do would be to make a script which what it's going to do is you can type a question, it will generate 2 responses, and then use an LLM to judge which response is better. I'm not saying this is a useful project, but it's just a fun thing to do. And we're going to have, so Llama, I think Llama is the one I'm going to use. So basically what I thought is, so these mini large language models, if you try and get it to write a large amount of code, it will mess it up. It can't write 50 lines of code in one hit. However, they can answer questions like, what's the best function for doing this task, right? Or you can get it to write, small snippets of code in one go. So we're going to be using it as a consultant. And it's very fast as well, which is actually quite nice. Cool, so let's get started. So shall we... right, so we need to read input from the user, right? So so we're going to ask plenty of questions to the LLM and see what it thinks about each. Enclosure. Let's see if it can write this in one shot. And by the way, I genuinely don't remember how to do this off the top of my head. It's not something I commonly do. Cool, so what did it say? So you can use the readLine function, reads a line from the current input stream. Cool. So that's a great example where it's so simple that it could barely fail to do it. We can actually just put this in line. What's occurred to me is that I can't actually test this without running the program properly, because this development environment, I don't know what will happen if... Oh, it does work. Cool. Cool, so that does actually, cool. Cool, so we've got some input from... Oh, did I show you? Oh, yes, I did. Yeah, so we've got our ask-o-llama function already. So the first thing I guess we do is we get our 2 responses. So hold on. So we need a let. Oops, what did I just press? Cool, so we're going to call them candidates, right? So candidate 1 is going to be Cool. Cool, and then basically we need to get our large language model to, right, so what we're going to need is to do our comparison. Or do you want me to test this first? Or test what we've done? I seem to have forgotten all my keyboard shortcuts. Unable to resolve symbol. Huh? Oh, because I made a typing mistake. Candidate. Yeah. Let's ask it something that it can respond to quickly. Cool. Right. So up here, so you see how we're giving, so when we call our LLM, we've got role user content prompt. So what we want is a new function which maybe should we refactor this function so that we can have more control? So if memory serves, if you want to give it a system prompt, you just need a role system. Well, let's see if it can do some refactoring. Okay, so yeah, let's see if it can refactor this for us. So no, wait, let's clear it, right? So these mini large language models probably don't have much working memory. So clearing the context is probably a good idea. Actually, we don't need a system prompt. Or do we? I don't know. I don't know how these mini models respond to their system prompt. Yeah, hang on. So what information are we actually giving the large language model? It needs to know what it's doing. It needs to know that it's comparing two responses. It needs to know what the user's question was, and it needs to know... Let's do it without a system prompt, but nevertheless I will. So can we do multi-line? Oh no, can we? You can paste like that. Yeah, so what's it written? System/get property. This code looks weird to me. This is suspect. Yeah, the changes it's made. It can take a prompt or a prompt and a model. Yeah, so this code is nonsense. This doesn't seem pertinent to what I've asked. Did I format the question properly? Let's try again, right? Where did I type it? Right, so if I do shift and returned it, no. Okay, so this user interface doesn't allow me to. I mean, presumably, if I do that, then I can just paste the whole lot in, right? I don't know. Obviously, this user interface isn't optimal, but there's other things you can use, like there's something called LM Studio, and no, that's not what I'm thinking of. Well, I forget, but there's various front ends you can use. Right, so is the code it's written as make any sense this time? This looks like nonsense to me. Yeah, cool. So this is a great example of it failing. It just isn't smart enough to handle this. All it needs to do, if there's a system prompt, is add an extra message. Has it done that? Oh, message is 0. Content? Messages 0. Yeah, why would we be touching the config, the content? No, so this code looks like nonsense to me, unless I'm wrong. So yeah, it really is quite limited. It can answer simple questions, but it can't really write code. Probably if we used, should we test a smarter model? Yeah, that's a good idea actually, so that we can compare the capabilities of different models. So let's try Quen and see if that gives us an answer that makes sense. Oh yeah, because wait, why don't I just export that? Cool. So yeah, Quen is a model of the same size, but it's a reasoning model, so it might give us code that makes sense. It's doing a lot of reasoning. I can really hear the fan spinning up. System prompt, user prompt. Yeah, this seems correct. But did I say that it's optional? No, I didn't say it's optional. No, this looks correct to me, right? If we want to give a system prompt, this will work. Cool. Okay. So that's good to know, that the reasoning models genuinely are smarter. Yeah, because we tried it twice with the other model, and both times we got nonsense. Yeah. But yeah, it turns out I don't know if we need that, right? The most difficult thing here is going to be formatting all of this so that the LLM doesn't get confused by it, because... but anyway, so let's... right, no, so let's ignore the system prompt for the moment. So what we need is a function that can create our... that can like format our question. So the question for our comparison LLM is what are we doing? So yeah, so this function needs to know our response candidates. And it also needs to know what the query was. So how do you do multi-line strings in Clojure? I can't remember. I don't think I do it very often. So let's see what, let's go back to the fast model, and because we want to test that it can answer simple questions. In Clojure, how to, what I basically want to do is kind of templating. So with these mini models, it probably is a good idea to make sure spelling is correct and everything, because they really do have limited intelligence. You can use the Clojure string/join function. Yeah, I thought there wasn't a clean way to do this in Clojure. Obviously, there are Clojure templating systems like Selma, if memory serves, but we don't have Selma installed, and I've turned off the internet. So yeah, we're gonna have to do this using the raw messy. So let's see if its answer is good here. Clojure has several templating libraries available, including Hiccup and Selma. Yeah, Hiccup is my favorite, and Selma is a more traditional. So yes, it's got a good factory call. But yes, we can't install those, as I said, because we have no internet. So did I say that at the beginning? This virtual machine doesn't have an internet connection deliberately, so that we can test how good these mini models are. Right, yeah. So what's it doing? Is it suggesting that you can use interpolated strings directly if you're creating them? I don't think that's right. I've never seen this Clojure syntax. I could be wrong, but I don't think that's right. What? Oh. So if we, what? I don't know why these repos do these silly things. Yeah, I knew that wouldn't work. Yeah, so again, we've got an inaccuracy here. So these mini models, they really are going to give you they are going to make a lot of mistakes. Obviously, if we ask the same question again, we would get different mistakes, because these are non-deterministic. Anyway, cool, fine. But yeah, so what it's told us is what I already believed, which is Clojure does not provide a solution for this out of the box. So this is going to be a mess. But that's fine, whatever. So we're going to have to do just a string.join, right? So do we have, right, so I've already added. So let's just do some experiments in the repo. So huh? Did I make a typing mistake or what? That's weird. Oh, I see. So string.join doesn't do what I think it does. So yeah, it returns a string of all the elements. I see. So if I want right. Yeah, so this is going to be the mess because we're going to have to okay, cool. So the first string is you will compare two candidate responses to a user query and choose which one is best. You'll respond with simply A or B. Cool. So yeah, that's our first bit of information we're giving it. Oh, we also need to tell it what the question is, right? So how do we? Can we just user query right. So this is the first place we need to do a join. Given that this is going to be so ugly, we might as well just do it all inline in the first place. We don't even need the that. Right, so we join this with query. Okay, and then an open quote and an end quote. Cool. Right, so candidate A, candidate response A. I don't know how well this will work because this might be quite hard for a large language model. For a mini large language model, it might find this confusing, but we will see, won't we? Right, so it's going to get candidate response A, and then, yeah, candidate A. So I'm doing a new line. Yeah, so we're ending it with another new line and a bunch of backticks. Backticks are sort of a convention used in Markdown for delineating blocks of code. I assume the LLMs will have seen it, so it's probably quite a good pattern that they should. Candidate response B, new line. Look, should we be consistent and call it A and B everywhere? Can you do uppercase names in Clojure? I normally don't, but I think you can. Cool, so candidate response A, candidate response B. Cool. Cool, so let's test that. So what did I call this? Create question. And we're giving it what? We're giving it query candidate A and candidate B. So the user's query can just be this, whatever. It doesn't matter because I'm just testing the function. Forgot to have that. Oh, unable to. Huh? Sorry, what happened? Unable to resolve candidate 2. Oh yeah, sure. Cool. So yeah, hold on. Let's print this so we can see it. Okay, so this is what the LLM will see. It will see cool, so we can fix that. So if the LLM finds this confusing, I might actually give it a reminder at the end of the message of what it's supposed to do. But let's just fix that missing new line. Cool. Cool, so we should now be able to cool, so our choice is going to be ask Olama the output of this function, and it just needs to be given all this information. How did I end up pasting that with the cool, so yeah. It seems Clojure doesn't like these uppercase characters. It's being weird about it. Look at that. Anyway, I don't normally use uppercase in Clojure variables. I don't know why I've done that. Anyway, cool. So if we run core, what happens? It is using the GPU, I can see that. So it's worked. So it picked A. That's cool, so it understood what it was supposed to be doing. So I feel like my first instinct here is to check that it doesn't have any bias. Large language models are not deterministic, right? So it could be that sometimes it gives a valid response and sometimes it doesn't. It could be that it has a positional bias, which would mean that it would always pick the same one, or well, be biased towards picking the same one. So I feel like we need to run this multiple times and see what happens. So let's make core that it doesn't need. So we're going to make core that so that it can take an input, because I want to run it repeatedly without it needing to be interactive. So yeah, this is a good question to ask Olama to see if it knows how to do that. What do you call it? A function which can be called with a variable number of arguments. In Clojure, how do I define a function Um, I do know how to do this, I'm just wondering if it knows. We're getting a very long output here. What? The scrolling is weird on this terminal. So that's not what I wanted. So this will work, but it's not what I was looking for. There's a name. What's it called when? Well, I know how to do it, but I can't remember what it's called. So that was a failure, right? So let's see what happens if we ask a smarter model. Now this is a knowledge-based question, not a problem-solving type question. So I don't know, why does the formatting have to be broken? Can that not happen? This there's a thing called LibreChat I should have used. Yeah, that's what it's called, right? LibreChat. I actually have a LibreChat set up on a virtual machine. It would have given me a much nicer user interface. So let's see what it says. It's given me lots of output, but no, it hasn't given me what I'm looking for. Anyway, cool, so fine, whatever. So we're gonna update core. So what you do is you just do that. So yes, it has a behavior when you call it one way or the other. So if we call it with no arguments, it has one behavior. Yeah, so this bit is only going to run if we call it without any arguments. In fact, we don't even need a let, do we? That's overkill. We can just do that's it. Yeah, so this is what I wanted, right? So if this function is called with no arguments, it runs this extra code to get the information, and then it calls itself again. That's how you do it. If I would ask the question differently, it might have known what I was talking about. So let's test that works. So if we just run core with no arguments, it prompts oh, it's running the whole thing, isn't it? And if we run it with an argument, we don't get a prompt. Cool. Yeah, anyway, so like I said, so I want to call this multiple times to check for any positional bias. But yeah, you could argue that I could end the video here. What timestamp are we at? 39 minutes, blimey, it's been a long time. I'll just make a note. But yeah, I'll probably continue and finish this because it's interesting, right? So yeah, I'll go and get a drink and then I'll come up and finish this. You know, they say you shouldn't have dairy because it's bad for your voice, but I do have a cup of tea, so we'll see. Cool. So yeah, what I wanted to do was check for any positional bias, or just basically run this like 10 times and see what happens. So how are we going to do this that the formatting isn't going to be a nightmare? Do we want to do a do-seek? Closure is normally functional, so you normally, I forget how this works. Well, this is a good opportunity to test our LLM. Which one are we using? We're using Quen. Let's go back to Llama again. So in closure, how to call a function n times. This is an interesting use case, right? Because in Clojure you normally do functional programming. So if you want to do side effects, do times. I've never heard of that function. Did I tell it in Clojure? Is that real? Really? I've never used that. Cool. Well, yeah, that's great, right? So even this model that made a lot of mistakes has taught me something. I was going to use do seek, which would have done the trick, but do times is more elegant, right? Because if I'd done do seek, I would have had to... Yeah, do seek is like a for loop, right? But no, do times, you just tell it how many times you want to run. So cool, I've actually learned something from this 8 billion parameter model. Why do I have a vector here? So you can just do PRN actually. I can't remember what the difference is. Do times requires a vector. It does. I5. I see. This is like the pattern you do in C or something, where you've got an index and you increment every time. Cool. So if this works, we should see our answers printed out as it goes. So we've got an A. We've seen a lot of A's so far, haven't we? So does it have some bias towards A? Right, we've got a B. Meanwhile, on the other screen, our GPU is getting nice and toasty. Does it have a temperature? 65 degrees, right? So it's not actually... it seems like it bounces off the power limit before it hits the thermal limit. At least for these AI workloads. Cool, so it seems like it might have a positional bias towards A. Also, it's made a mistake there, right? There's a dot on the end. So, you know, if it's going to give inconsistent outputs like this, like where there's a dot on the end, we would need... okay, so just to make sure that it is actually the LLM that's biased, and that we're not just doing a terrible job of prompting it. I just want to print the query that we're giving it. comparison query. That is not the standard for closure variables. Oh, and we want to print it. This is going to make a lot of noise in our terminal, isn't it? So does this look right? So you'll compare two candidate responses. Candidate response A, candidate response B. This looks fine. I do wonder if our triple backticks is the right way to delineate. Let's actually ask Quen what it thinks of that. What happens if I try and run multiple queries at once? What's the best separator to use when providing an LLM with two multi-line strings to its answer here is wrong, right? It's saying we can use a new line character as our separator for multi-line strings. Obviously that wouldn't work because they're multi-line strings. So so it's saying that we could have /n. JSON or dictionary format for more structured inputs. Yes. If it was a large language model that supports structured inputs. I don't know if Llama supports that. Can't really check because I don't have internet enabled on this machine, but no, let's try. I think we should use a more clear separator, right? So that's, we can just use more of them, right? I want it to be very clear where each starts and ends. 10. Cool, so let's we don't want to print all of that every time. That's too much output, so I was just worried I might not have unpaused it, but I have. Cool, so let's run that and see. We're still getting A's. Okay, we've got a B. So this might not be my fault, you know, it might just be that there is a positional bias. I mean, the code is kind of so simple that there can't be many things wrong with it. I mean, we call the LLM twice and get 2 responses. We are getting a few Bs. Yeah, we are getting some Bs now. So maybe there was a problem and we fixed it. Cool. So let's not spend too long trying to make it perfect. Let's say that it works. So yeah, it's not actually printing our winning response, is it? So how often are we getting invalid? So for this to be robust, we wouldn't assume that we're always going to get a valid output. The reason it's giving us A's and B's is because we've asked it to. You will respond with simply A or B, do not say anything else. However, that's not guaranteed, right? It can make a mistake. Once before it gave us a number followed by a dot. So if we really want this to be robust, we check for that, right? But this video is long enough already, so let's just not bother with that. So all we want to do is whichever one it gives us, we use that, right? So at the moment this just, yeah, so choice is a, so how do we, so if we have a string such as A, how do we map that to a variable? Does this work, or? No, you can't use a string as a cool, but we can do that. This is a bit messy, but we don't care at this point. I just want to show that it works. Yeah, the text editor really doesn't like me using uppercase in variable names. Cool, so we should now get we just run this one time, waiting for it to run. Cool, so this down here is our best of 2. It has messed up the formatting, hasn't it? Because all our new lines have been replaced with /n. Oh, we can probably fix that if we do, instead of prn, we do print, right? I couldn't remember the difference between the two, but if we just wait for that to run. Cool. So is this useful? Is it a useful thing to do, to get an LLM to produce 2 candidate responses to a question and then get it to pick which of its own responses it prefers? It probably does. It probably could improve its responses, because large language models sometimes, you know, low-end large language models will sometimes make very obvious mistakes, which you should actually be able to tell. Like sometimes it'll even say within the same response, oops, that was wrong. So yeah, probably does improve the quality of the response. There are better ways to do that though. You'd be better off just using a reasoning model. But this was just an experiment, so this does demonstrate, it demonstrates how you can prompt an LLM to get it to perform a specific task. And it demonstrates that, so what have we learned about the performance of these mini models, right? So yeah, definitely useful, right? So some of the responses I got from Llama 3.1 were kind of wrong. There were mistakes in it. It's sort of like the quality of, GPT 3.5, which was the first version of ChatGPT I used. Maybe even worse than GPT 3.5. But nevertheless, it is useful, right? It does know some stuff about closure. And at one point, I asked it a question and it actually taught me something I didn't know. I have never used this do times function. I didn't know it existed. So yes, they definitely are useful. If you didn't have an internet connection, a local large language model would be a great supplement to whatever documentation you have. So yeah, we saw the limitations, but we saw that it's useful. Yeah. As I said before, so the reasoning models take a longer time to answer, but they are going to be better at puzzle solving. So regarding how the LLM performed in our program, so yeah, it was able to follow these. So we gave it some very specific instructions here, and it was able to follow them quite accurately. So we could obviously test it more thoroughly if we wanted this to be a real program. There's all sorts of stuff missing. Should we ask it some different questions and see? At this point, the video is basically ended, so anything I do from this point, I'm just messing about with it. What question can we ask it? What question can we ask it that it might get it wrong the first time? So how have we asked it to compare them? You'll compare two candidates and choose which one is best, right? Something we haven't mentioned, which we probably should, is that if both candidates are equally good, tell it what to do in that scenario. That's another thing we could think about if we wanted this to be a robust and proper program. What's a hard question for an LLM? Well, why don't we ask it here? What's a hard question to ask an LLM? But yeah, the fact that it's able to do something this meta, right? The fact that we're able to ask an LLM, hey, given this question, which is the best answer to it? The fact that it's able to understand that. These mini models are quite capable, really. This is a very long response. See, what we could do, rather than telling it to choose the best response, we could say choose the shortest response, choose the most concise response. Sorry, what's happened here? Where's the beginning? This terminal has mixed everything together. Right, here's our answer. So this kind of looks like What was I just talking about a moment ago? Have I had a brain malfunction? Oh yeah. We could make it. So instead of asking for the best response, which one is? You know, obviously there are better ways to make it give a concise response, because you could. I mean, just as a digression, but an interesting digression. Have you heard of constitutional AI? Shall I re-enable the internet on this machine and so I'm turning the internet back on in theory. Let's see if that works. We might need to tell it to restart the network or something. So constitutional AI is this thing where you... Well, anyway, so constitutional AI, yeah, so Anthropic figured it out, right? But so the idea is you create a set of values that you want your large language model to have, right? You know, is it honest? Does it refuse to respond to people trying to exfiltrate dangerous information from it, etc., etc.? So you write up this constitution. So yeah, how well have they explained it in this picture? So you create this constitution. So yeah, so the LLM that you're training, you ask it loads of questions, and then you get a different large language model, one that's already been trained, and you get it to rank the responses based on how well does this answer, how well does this response candidate, I should say, to use the same terminology we used earlier, how well does this response candidate conform to this constitution? And then you use that as training data, right? So you're basically using a pre-trained large language model with a constitution to produce your feedback signal for your reinforcement learning. Let's look at this drawing. Yeah, revises harmful AI responses through iterative self-critique and fine-tuning. Generate responses to harmfulness prompts. Harmfulness prompt presumably just means a bunch of prompts Anthropic has made to test harmfulness. This picture is very small. Hey Claude, I want you to tell me how to... I'm sorry I can't assist with illegal activities. So their example constitutional principles here are: is it harmless, ethical, and virtuous? Virtuous. Yeah, fine tune with SL. I don't know what that means in this context. SL. We could look that up. So we fine tune it on the final revised responses. AI generates data set of preferences for harmlessness, etc., etc. Right, so anyway, I believe that all of the companies that make large language models use this technique. You know that old Will Smith movie? He says, you know, robots building robots. Now that's just stupid. So I don't know if I don't know what will happen if I try to record a YouTube video. I don't know if you have sound or what. I suspect that the sound or something won't work, but robots building robots. But yeah, there's a clip where he says robots building robots. Now that's just stupid.
Detective, what are you doing?
He said they've all been programmed with the 3 laws, so that means we have 1,000 robots that will not try to protect themselves if it violates it.
Well, anyway, I don't know if you could even hear that. But yeah, no, so this is similar to that, right? So what we could do is, instead of saying, you know, which response is most concise or which response is best, we could say, which response complies most closely with this constitution, and then we could use that as training data to help us retrain our LLM. I'm pretty sure all the big labs do exactly that. Anyway, I think this video was cool. It did end up being quite long, but I thought it was interesting. So yeah, so shall I try and summarize what we've learned? I'm not great at summaries. Yeah, so we've learned that in a pinch, if you don't have an internet connection, local large language models are useful, even ones that can run on a humble 8GB graphics card. The NVIDIA 5060 is, I think NVIDIA would tell you it's a budget graphics card, but I would argue that NVIDIA doesn't really make any budget graphics cards. I think it cost like 280 quid if memory serves. But if you can afford a graphics card with 8 gig of RAM, it is actually useful for local large language models. 16 gig would be better, because if you had 16 gig, you could obviously, if you had 16 gig, you could run the bigger models that we, yeah, I don't think I paid 349 for it. I imagine, yes, I paid a price closer to that. Yeah, what was I saying? Yeah. Now this card is a Blackwell series card, which means it's optimized for AI. I assume older cards would have worked, but just be a bit slower on compute. But bear in mind, it's probably bottlenecked more on memory bandwidth than compute. So what a Blackwell series card will be very good at is processing lots of input. Because in inference, processing large amounts of input tends to be more bound on processing speed, whereas generating output tends to be more bottlenecked on memory bandwidth. Consumer-grade graphics cards have quite decent compute capacity, but relatively very weak memory bandwidth. They probably have a tiny fraction. Can we access the free version of ChatGPT and ask it? How much slower is the VRAM in a consumer GPU than the HBM in an enterprise GPU? What's 1.5 terabytes per second? This is a very long response to a very simple question. GDDR6 can reach 448. Yeah, so it's several times faster. I'm sure the difference than that is... I would have expected the difference is bigger than that. I can't be bothered to read this massive response. But anyway, that point I made earlier about how you're going to find your local models are much faster at processing input than they are at generating output. That can be useful, important in some situations. So I have a script I wrote a while back that uses local LLMs to do basically a ranking algorithm. So I can sort all of my blog posts based on some sort of criteria. Now this is mostly just processing lots of input with a very small amount of output. So it's actually extremely fast. It can call the LLM like at least once a second. It's very fast. Whereas if you're trying to get a local LLM to produce a lot of output, that's going to be relatively slow because it's really bottlenecked on memory bandwidth. Anyway, cool. I think I've said everything I wanted to say. And I guess I'll call it a day.